Welcome back to Low Stress Math with Mrs. Bono. Chapter 1, Exponents. We are starting today with the power rule. I love the title, Power. Because it has so much power. All right, so the target today is to learn the power rule of exponents and apply it. So what are we doing here today? We are learning and applying the power rule. Okay, now time for the warm-up. Pause the video and try the warm-up. You know, vocabulary is key to math. Okay, welcome back. Now, look at that negative sign in front of the A. You know that means really it's -1 times A cubed. I like to write in color so you see what I'm talking about here. So the coefficient was an invisible -1. So my coefficient is -1. The base is A, and the exponent is 3. Now over here, my coefficient is a fraction, but that's not a problem. I'm good with that. So 1/3. The base is M, and the exponent is 2. Now I don't have to expand anything, I don't have to solve anything. That's good enough, just a little vocabulary review before we get started. All right, now we're gonna do some examples. So, expand and simplify this expression. I have x squared in parentheses. So the base is x squared. We've not had that before. We haven't had a base that had an exponent before. So I'm just gonna kind of write that over here. The base is in parentheses x squared. And I'm gonna use my exponent, 3, to write the base 3 times. So I'm writing this base 3 times. So x squared times x squared times x squared. Oh no, what did I do? I made a mistake. You can't make mistakes, Bono. There's not enough whiteout in the world for you. Here we go. The squared has to stay inside the parentheses because it's part of the base. But now I'm going to expand some more. I'm going to expand each one of these bases. So x squared, x times x. X squared, x times x. X squared, x times x. And now I have 1, 2, 3, 4, 5, 6. I have base x to the 6th power. Or, I could be looking up at here and I still have a base x, but now I'm multiplying, right? That's what those parentheses mean. So I'm gonna add my exponents, 2 plus 2 plus 2. 2 plus 2 plus 2. And I still get x to the 6th power. So it didn't matter if I added the exponents at this step and got x to the 6th power, or if I expanded it some more, I still get x to the 6th power. So this, no matter how you write it, is going to be my answer. All right. Now I have to do these two. Look at all this space I was given for that. I don't think I need all that space. I probably should move that. All right, whatever, Bono, stop mumbling. Here we go. Now I'm again using 2 to the 4th power as the base, and I'm expanding it, so I'm using it 3 times. 2 to the 4th power as a base 3 times. So 2 to the 4th times 2 to the 4th times 2 to the, oh, don't write it tiny like that. I almost wrote it so it looked like 24. I got to be more careful. 2 to the 4th. Make sure when you're writing your exponents up and to the right. Now, I could expand this. 2 times 2 times 2 times 2. And then I could expand the second one. 2 times 2 times 2 times 2. I could expand this one. 2 times 2 times 2 times 2. I have now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 2 to the 12th power. Or I could have come up here and done 2 and added 4 plus 4 plus 4. Wait a second, I'm repeatedly adding. What is another word for repeated addition? Think about it. What's another word for repeated addition? Ah, that's multiplication, isn't it? There's another way I could have done this. I could take this back down here, 2 to the 4th power, and now I'm taking that to the 3rd power, and that is going to be 2 to the 4 times 3, 2, and I'm going to multiply my powers, 4 times 3, and I get 2 to the 12th power. Now there's 1, 2, 3 different ways I end up with 2 to the 12th power. I can expand it slightly and then use the product rule. I can expand it completely, get a little bit of writer's cramp, and I still get 2 to the 12th power. Or I can use this new rule where I'm multiplying, and I get 2 to the 12th power. Since I didn't give myself a lot of room, I'm going to just kind of do the shortcut down here. I'm going to use x, and I'm going to multiply 6 times 2. So I have x to the 6th power, and that is all the way squared. So if I expand it, I would get x times, yes, I know. I'd get x times 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 x. 1, 2, 3, 4. Oh, almost lost an x. See, that's the problem with expanding it. Sometimes you'll lose your x's. And I end up with x to the 12th power. Or I could just do that shortcut and multiply x to the 6 times 2. And I still get x to the 12th power. I love that shortcut, and that is the power rule. So, power rule, when you have one base raised to 2 powers, okay, so here's how it works. When you have one base raised to 2. Look at that, 2 different 2's in one sentence. When you have one base raised to 2 powers, not Bowers. No. I can just fix that a little bit. 2 powers. When you have one base raised to 2 powers, comma, here's the important part. I'm going to write this in red. Keep the base. Be careful. Keep the base. Then then multiply the exponents. Ha, that's going to be good. All right. When you have one base raised to two different powers, well, they don't have to be different, they could be the same. When you have one base raised to two powers, keep the base, then multiply the exponent. So let's, the power rule algebraically. Remember, algebraically means you're just using variables in place of numbers. And you're going to have to do a lot of things in algebraically, well, obviously. So what am I doing here? I'm multiplying m times n. I'm multiplying what's outside times what's inside. All right. There's a lot of space here because it's important. Maybe we should put a big puffy cloud around it of importance. And maybe a little thought bubble going down to a crazy bona fide thinker. Hey, yeah. Here's me. I'm thinking good math thoughts. If I have two powers, one inside a parenthesis, one outside, I'm going to multiply them. So use the power rule to simplify the following expressions. I'm going to give you a minute. I want you to try those on your own. Just keep the base, multiply the powers. Welcome back. Here's my base, 10, and I'm going to multiply 4 times 5. Multiply both those powers. And I get 10 to the 4 times 5, 20th power. Not bad. Keep the x. Now I'm multiplying 8 times 6. 8 times 6. Let's see, 6 and 6 is 12, 24, 48. Okay. X to the 48th power. All right. Down here, keep the base, x, multiply the exponents. -3 times 2. Let's see, -3 times 2. X to the -6 power. Sometimes your exponents are negative. It's okay. Keep the base. And my base is in 2 sets of parentheses here. These inner parentheses are what you're used to, but these outer parentheses are called brackets, and they work exactly the same way as regular parentheses. And on a calculator, you would just push the parenthesis sign twice. I'm going to show you this one in the calculator because it's interesting. And I'm going to do 4 times 7. And that's going to give me 1/2 to the 28th power. And I want to do this one in the calculator because I want you to see how you would put it in a calculator. Let me just grab that right here. And can you see it? Here's my parentheses. So I would put in parenthesis, parenthesis, because see, it's 2 parentheses. That bracket is a parenthesis, 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 and I have 1/2, 1 over 2. So remember, you're using this little n over d, but now I'm on the bottom of the fraction, so I'm going to push this right arrow, so now I'm off it, and I'm going to put 1 parenthesis, because see, I have 1 parenthesis, and it's to the 4th power. So then you have this little arrow up there to the 4th power. Now you have to get off the exponent, so off the exponent, and another parenthesis, and now it's to the 7th power, so that up arrow to the 7th power. And when I hit enter, oh my goodness, I don't want that. I want, oh dear, dear, dear. That just makes it worse. I wonder what happened. Dun, 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 dun. We're going to learn about fractions with exponents again. Nope, that's enough for now. Talk to you later.